Hello, welcome to River Canal Rescue's Key Diesels department. This is where we do our training and all of our main engine remanufacturers, gearboxes, injection pumps, everything. And we're here for one of our how-to videos. And today we're going to be looking at fan belts, checking them, adjusting them, figuring out what they're for. So let's get into it. The primary function of fan belts or drive belts, depending on what you call them, is to transfer power from the engine to ancillary components. Water pump is the main component that the drive belt is designed to power, and it's really important because the water pump drives water around the engine and therefore make sure the engine doesn't overheat. The secondary part of what a drive belt does, and sometimes if they have a second belt, it's designed specifically to drive alternators. Alternators are a generator. They're usually a DC generator that provide power to the batteries at the same voltage that the batteries exist. So if you have a 12 volt system, you'll have a 12 volt alternator, and so on and so forth. Now what's important with drive belts is that they're geared. So as we can see down here, this has quite a large pulley on the engine and a very small pulley on the alternator. That's designed to step up the amount of rotations the alternator does alongside what rotation the engine's doing. And that's quite important because a lot of the alternators we use in marine come from the automotive industry. And as you know, with cars, most of the time they're sat around about 2,000, 2,500 RPM. So alternators are designed with that in mind. Now, unfortunately, marine engines tend to sit around 1,200 to 1,500 RPM. So they're never in the peak range for the alternator producing its maximum power output. So what we do is we step up either the size of the engine pulley or we drop down the size of the alternator pulley to compensate. What that means is that smaller increments of engine rev increases exponentially drive the alternator at higher and higher RPMs. So unlike with a car where generally the engine rotation matches the alternator rotation because that's what it's required, on a boat it's maybe 2 to 1. Depending on the alternator. Now you will notice that a big pulley driving a little pulley means the big pulley's got lots and lots of pressure on the belt, the little pulley has hardly any. The bigger the step up, the more tension has to be on the small pulley for it to drive. So what we're looking for with drive belts is that they're adjusted to the correct tension. Incorrect tension happens for one of two reasons. One is it's too loose and therefore doesn't have enough surface friction to drive the pulley. The other one is that it's too tight and therefore it's putting too much load through the bearings of whatever component it's driving. By putting too much load through, you shorten the life. By putting too little load through, you don't get the functionality, so it doesn't turn as much or not at all in some cases. So first things first, we'll go around how to check a drive belt. So first thing you want to do is get your hand on it while the engine is not running and just have a feel. Now, as you can see here, we've got a lot of movement in this belt and a lot of movement in this belt. So instantly, we're not feeling any resistance. We know that that belt's probably loose. A really nice, easy way of checking that, especially if you've got a nice water pump pulley, is you can actually hold the water pump. And if you can spin that without that turning the engine, it's too loose. It's a really nice, easy way of checking. Now, there's slightly different variations on checks depending on whether it's a V belt or a flat belt. And that the V or the flat just relates to whether the belt is flat in shape or has a V shape to the bottom side of it. So with a V belt, we're really reliant on that movement to figure out what the correct tautness is. And what we want to be looking for is around about a finger's length of wiggle. So we're just going to go through and adjust this belt because it needs it. And just to show you really what we're going for. Slightly before that, we can do a quick check by just rotating the belt so we can see the underside. Just checking to see whether there's wear on the sides, any cracks or deformation appearing, or if it's shiny, because shiny is a real clear sight that the belt's been slipping. So in this case, it's a 13mm spanner. Now what we're looking for is the adjusting arm. Now alternators will be mounted in 2 or 3 places. They'll have either 1 or 2 main mounting bolts that attach it firmly to the engine, and then we'll have 1 mounting position that has either a slot or a adjuster attached to it, and that's the one we want to go for. Now preferably we don't want to undo the main mounting bolt. We'd like that to be stiff throughout. So once we've found it, we're just going to undo it. It doesn't have to be undone all the way, just 1 turn or 2, just so that it loosens off the bracket. And then we're going to try and move the alternator. Now in this case, the alternator's moved freely. That's not always the case. Sometimes you have to get a pry bar or something bigger, and you're going to get in beside it, and you're going to use that as a lever to wedge against the alternator and push it away. Now if the main mounting bolts are loose, you will find at this point that there's a lot of flex there, and that if you do that, the alternator will move. Now the problem with that is when you go to adjust it, every time you go to tighten the bolt, it's already gone too slack. So if you find that, you need to tighten those bolts at the bottom so that once you get it into a position where the belt's in the correct tension, it will hold itself there while you tighten it up. So we're just going to go ahead. I'm just going to hold on to this one because it is slightly loose. And what we're looking for is that, just a slight finger's width of movement. And when we grab hold of that pulley, it's really hard to turn. In fact, it's trying to turn the engine over while I'm doing it. But it's not so tight that it's compressing this bearing. So once we have that, then we're going to go ahead and we're going to tighten this bolt. Now, as you can see, I'm going to put a lot more pressure through that, and that pulley is really tight, indicating that we've got it to the right tension. So next we're going to go with the flat belt, which is slightly different. Now flat belts have to be a little bit tauter because they're usually driving a much smaller pulley with a big pulley on the other end. Now, because we don't want to over tighten them, the process for figuring out whether or not it's the right tension is rotating the belt. Now you should be able to easily rotate to the 90-degree mark. It should then become much more difficult to go any further, and you should really feel the difference in that tension. If you're finding that you can go all the way over, then it's definitely too loose. So if we're going to go through the same process, now sometimes they have an adjuster, sometimes they have just a bar like this. So see if it moves, and it doesn't. Which is perfect how we go about adjusting. So you can pretty much use anything. The preference is to use something soft so that you're not damaging anything on the engine. But you're going to go down and you're going to find somewhere where you've got a nice solid thing to lever onto. And if you can't get it on that one, don't worry. And then you're going to lever that across. There we go. So you can see I'm putting tension on it, and then I'm going to adjust the tension on it as I feel. So I can get to around about just past 90 degrees. So I'm going to go a little bit tighter. And as soon as I start feeling that tension building exactly at the 90-degree mark, we know that we're in the right spot. Now, when you let go, if the alternator brackets are tight, it will maintain that. But as you can see, as soon as I adjusted that, it moved back. So what we're going to do is we're going to adjust it up to the right point. See whether we can get it tight enough without adjusting. So as we can see, we've got it perfect. So if that bottom mount is not tight, you will find that it will come back on its own. You must make sure that main bolt is tight, so that when you adjust it to the correct position, it holds itself in place while you tighten up. Otherwise, you'll be continuously going around trying to figure out how to keep that alternator in a particular position while you tighten up them bolts. So that's it on this engine. We're just going to quickly skip to a different engine with a very different setup. and just show you how it's exactly the same but can look very different. Alright, so we're on to the next engine, and as you can see, this one has a bit of a unique design whereby we have one V-belt but it's driving two separate alternators. Now, the obvious ramification for that is that this belt is having to do much more work than you would expect with a normal belt setup. Now, because of that, the belts have to be a little bit tighter, and you have to be on top of the belt adjustment much more vigilantly, because they will come loose way more often. Now, the checks are the same, so I'm going to check with the water pump, and as we can see, because I loosened it earlier, this one is already too loose, and you can spin that water pump pulley freely. But alternatively, when we have a feel of it, you can see that there's obvious slack there. So we're going to be looking in the same way as we were before. So each alternator will have a mounting point and an adjustment point. Now, what's unique about this, because we only have one belt driving two alternators, the second alternator has a fixed adjustment bracket, which means we only have to adjust one alternator to get both alternators tight. So we can see the main mounting bolts here, and we can see the adjustment bracket here. Obvious that you can slide this within this slot here to make it either tighter or looser. So I kept on me the spanners and bits and pieces I used on the last one, because ultimately when you're working with fan belts, they all use very similar sized bolts and bits and pieces like that. So what you use for one, you'll likely get away with on others. So it should, and it is, be a 13mm spanner. So we're just going to loosen off this adjustment bolt and see whether or not we've got any movement there. So we haven't, so we know this is nice and tight, so that's a first really good sign. So we're going to go with the same process, any old lever really. I particularly like hammers because they come with a really soft handle. And we're looking for something where you're not going to break anything, but you can just lever against. And as you can see, I've got real nice adjustment on that alternator. So we're going to do the same process. We're looking for not too tight. We want around about a finger's wiggle. And then we're just going to tighten that bolt up. Now, it's a lot easier doing while we're stood next to the boat. When you're on top of it, you have to figure out a way of having one hand do this and another hand doing this. On this engine, the bolt threads directly into the alternator, whereas on most engines there's a nut at the back, which means you need two hands to do the bolt. So how do you get the adjustment on there? Which again is why it's really important to have that main bolt really tight. So we just adjusted it up there. We can see that it's really good. We can have a look underside of it, and when we try and move that pulley, we get nothing. And that's as easy as fan belt checks and adjustment are. So before we finish, I've just got a few examples of where we have belts that have gone bad. So this one here, we can start to see the top section is fraying, which is indicating that it's well past its due date. Now that's usually weather that does that, or just old age. It's been sat in a damp environment and thereby it started falling to pieces. But one of the telltale signs is when we invert it, you can see all the cracking appearing within the beading of the rubber. What that's saying is the rubber's now deteriorate to a point whereby it's not actually holding form, which means that that is really at risk of falling apart and breaking completely. So we have another one here. Now this one, you can see it looks a little bit better than the last, but we've started getting this. Now what that is a separation of the fabric insert at the top. And the reason that's happening is that it's been wearing away on the side. So the pulley has actually been eating into the side of this belt, and you can see how shiny it is. Now what happens is it gets super hot, it wears away, and then the belt gets thinner and thinner and thinner. And conversely, the thinner it gets, the less surface area, and so the less friction you have on the pulley. So you have this compounding effect whereby the wear of the belt makes it mean that it needs to be tighter and tighter and tighter, and you're getting less and less and less friction. But we have the same problem. We turn it inside out and you can see it's all cracked, it's all corroded, and it's well ready for a change. So we've got a few less observable ones. So on this one here, we can actually just see the belt itself seems in good condition. It's moving around, there's no obvious cracks or deformations, but we have started getting this real discoloration to the top. Now that's a really good sign that that belt's ready for a change. If it started getting all of this carbon coating, that carbon's got to have come from somewhere, and it's likely from wear on the underside of here. Now, if you've been getting carbon dust appearing, it's time for a belt change, and it's certainly time for checking the adjustment on your belt. And a couple more. So this one's an interesting one. So if you were to look at this, do the inverted test, there's no cracking, it seems okay. But when we look at how thin it is, what's been happening is the same as on that last one. It's been wearing away slowly but surely, but because it's a fairly new belt, it looks like it's in good condition, just super thin. Now, the reason this happens is usually because there's corrosion on the pulley. And if there's corrosion on the pulley, there's an abrasive surface that rubs against the side, and it literally shaves away the side of the fan belt. But what it means is you don't get the same level of shininess, and it doesn't deteriorate the rubber on the belt itself. So this is an interesting one. If you're looking for that really thin side profile, that tells you that it's wearing away, but it's not a belt replacement that's required, it's a pulley clean. It's going to be the hardest one. So this one, by all intents and purposes, is in great condition. But what we'll notice, I don't know if you can see this, but there's a obvious concave to the top profile. Now, if you're getting that, what's happened is it has worn away, but the top hasn't, which means that the belt isn't fully sitting into the pulley, which is correct. But what we've got is we've got wear there that's being obscured by the top section. And the only way of seeing it is seeing that sort of concave dipping of that top profile. If you see that, the belt is ready for changing, even if the belt's working and it seems in good condition. So that's fan belt checking for us. So I think next time we'll be looking at something different, maybe some fuel bleeding process, and we'll look forward to showing you through that. Thank you.